The Fermi Paradox, where is everyone? With over 100 billion stars in our galaxy alone, each one potentially hosting multiple planets, it's hard not to wonder, why haven't we found signs of alien life yet? The universe is a pretty big place, vast and seemingly infinite, full of billions of stars, many with planets orbiting them. We're finding more planets all the time in our Milky Way, each discovery adding to the cosmic tapestry. So, if there are so many stars and planets, the odds seem favorable. The odds seem good that there's life out there, maybe even intelligent life waiting to be discovered, civilizations that have been around for millions of years, evolving and advancing, with technology we can only dream of. So where are they? Why haven't we seen any signs? Why haven't we heard from them? That's the Fermi Paradox, a perplexing question. In 1950, physicist Enrico Fermi asked, "Where is everybody?" during a casual lunch conversation, pointing out this strange contradiction between high probability and lack of evidence. Given the age and size of the universe, it seems statistically inevitable. Statistically, there should be other civilizations out there. Some should be far more advanced than us, with technology that surpasses our wildest imaginations, with ample time to spread across the galaxy, maybe even visit us. Yet we see no evidence, but we haven't seen a single shred of evidence, no radio signals, no spaceships, no alien artifacts. The universe is ancient, almost unfathomably old, almost 14 billion years old, a timeline that boggles the mind. Our galaxy, the Milky Way, is about 13 billion years old, a significant portion of that cosmic history. Even traveling at a fraction of the speed of light, civilizations could have colonized the entire galaxy by now. Civilizations could have spread their influence, leaving traces of their existence. The Drake equation, developed by astronomer Frank Drake, attempts to quantify the number of active, communicative extraterrestrial civilizations in the Milky Way. It factors in star formation rates, planets, and potential for life. Even with conservative estimates, it suggests multiple civilizations in our galaxy alone could communicate across interstellar distances. And yet, silence. A profound, unsettling silence. The Fermi Paradox forces us to confront profound questions about our place in the universe, our future, and the nature of life itself. One intriguing solution to the Fermi Paradox is the Great Filter. It suggests a massive roadblock on the path from simple life to a galaxy-spanning civilization. Most life forms get wiped out early on, never making it past the first few hurdles. But a select few manage to overcome those initial challenges. Then they hit the Great Filter. This filter could be anything: a cosmic disaster, a technological hurdle, or something we haven't considered. If the Great Filter is behind us, we're incredibly lucky. We've already made it through, defying the odds. But if it lies ahead, there's a wall we might not make it through. It could be a self-destructive tendency we haven't recognized yet. The Great Filter forces us to confront the possibility that our existence might be an anomaly. Are we just blips on the cosmic radar, flashes of intelligence that burn bright for a short time and then vanish? We humans are a paradox, capable of incredible creation and unimaginable destruction. This brings us to the self-destruction hypothesis. What if intelligent civilizations inevitably develop the means to destroy themselves? And what if they often do it? We've already created weapons capable of wiping out our species. As our technology advances, so does our capacity for self-destruction. It's not just about weapons. Climate change, AI, and genetic engineering also pose risks. Is this self-destructive tendency inherent to intelligent life, or can we overcome it? The self-destruction hypothesis suggests civilizations might flicker into existence, only to be snuffed out by their own hand. It's a chilling thought, but one we need to take seriously. To solve the Fermi Paradox, we need to understand our own capacity for self-destruction. We must figure out a way to break the cycle. The Zoo hypothesis. Are we being watched? Imagine the galaxy teeming with intelligent life. But they know we're here and choose not to contact us. They're observing us from afar, like scientists studying a newly discovered species. Maybe they're waiting for us to reach a certain level of development. Perhaps they're worried we're too primitive, violent, or unpredictable. It's like the Star Trek Prime Directive: advanced civilizations shouldn't interfere with less developed ones. Maybe they're studying us, learning about our behavior and potential. If you were an advanced alien civilization, wouldn't you hesitate to contact a species still figuring things out? The Zoo hypothesis is speculative, but it raises interesting questions about our place in the universe. Are we alone, or are we being watched by forces beyond our comprehension? The rare Earth hypothesis, a cosmic fluke? What if we're incredibly, improbably special? What if the conditions that make Earth so hospitable to life are a 1 in a billion occurrence? The rare Earth hypothesis proposes that the conditions for complex life on Earth are so specific they might not be replicated elsewhere in the universe. Earth is situated in the habitable zone, often referred to as the Goldilocks zone, where conditions are just right for liquid water. It also has a protective magnetic field and a stabilizing moon, both crucial for maintaining life. Plate tectonics play a vital role in regulating our climate and driving geological diversity, which in turn supports a wide range of ecosystems. It's like winning the cosmic lottery multiple times over. Each of these factors alone is rare, but together, they create a perfect environment for complex life. The rare Earth hypothesis suggests that complex life requires a perfect storm of conditions, a delicate balance that might be incredibly rare in the universe. While other planets might harbor simple life forms, such as bacteria or single-celled organisms, the leap to complex, multicellular life is a monumental one. Earth could be a cosmic anomaly, a fluke of nature, where all the right conditions came together in just the right way. This doesn't mean the universe is devoid of life, just that life capable of building spaceships, creating art and pondering its own existence might be the exception rather than the rule. We could be the outliers, the cosmic oddballs who hit the jackpot in the grand lottery of existence. The rare Earth hypothesis makes you appreciate how precious and fragile life on Earth is, highlighting the unique set of circumstances that allow us to thrive. If we are truly alone, it's our duty to protect and preserve the only known cradle of life in the vast, mysterious cosmos. The simulation hypothesis. Is this all just a game? What if everything we perceive as real is part of a sophisticated computer simulation? Imagine for a moment that our entire existence, every moment of our lives, is just a series of ones and zeros, a digital construct created by an advanced civilization. If a civilization can create realistic simulations of universes, it's possible they'd create many such simulations. These simulations could be so detailed and immersive that the beings within them would have no idea they were part of a virtual reality. Statistically, it's more likely we're living in one of those simulations than in the original, real universe. The sheer number of potential simulated realities could vastly outnumber the single base reality. Our computer simulations are getting more complex every day. From video games to virtual reality, we are already creating worlds within worlds. Imagine a civilization thousands or millions of years ahead of us. Their technological capabilities would be beyond our comprehension, allowing them to create simulations indistinguishable from reality. Their simulations would be so advanced, we wouldn't know we were in one. Every detail, every sensation, would be meticulously crafted to mimic the real world. If we are in a simulation, it could explain the Fermi Paradox. The apparent absence of extraterrestrial civilizations might be a result of the simulation's design. Maybe our simulated universe isn't programmed to include other intelligent life. Or perhaps the parameters of our simulation are set to keep us isolated, or the simulation's parameters prevent us from discovering the truth. There could be built-in limitations that keep us from uncovering the nature of our existence. The simulation hypothesis forces us to question the nature of reality. What is real? How do we define our existence if everything we know could be an illusion? How would we know if we weren't in the base reality? The lines between the real and the simulated blur, leaving us to ponder the true nature of our universe. It suggests our understanding of the universe might be fundamentally flawed. We might be just a small part of a grander design, a digital tapestry woven by an unseen hand. The Unending Quest. So where is everyone? The truth is, we don't know. Whether it's the Great Filter, self-destruction, or an alien zoo, the Fermi Paradox remains one of the most fascinating questions in science. As we explore the cosmos, we might uncover the answers. Or perhaps the silence is the answer itself. Maybe we're alone, a beacon of consciousness in an otherwise silent universe. Or maybe we're on the verge of a discovery that will change everything we know about our place in the cosmos. Perhaps other civilizations are out there, waiting for us to join the galactic conversation. Until then, keep looking up. The universe might be stranger and more wonderful than we can imagine. If you enjoyed this deep dive into the Fermi Paradox, be sure to like, subscribe, and hit that notification bell for more space mysteries. See you next time.